So, artificial intelligence is poised to completely change medicine. But that brings up a really big question. How do we actually grade it? I mean, how do we know if we can trust an AI with something as important as our health? To figure that out, we've got to learn how to decode its report card.
Okay, take a look at this. I know at first glance it kind of looks like a crazy plate of spaghetti, right? But this is actually an incredibly sophisticated report card for a medical AI. It holds the key to understanding just how good an AI is at spotting different diseases, and today we're going to decode it together.
So, before we can even begin to make sense of that chart, we have to get back to basics. What is the fundamental job that we're asking this AI to do in the first place?
Let's simplify things a bit. Think about something you use every single day, your email spam filter. For every single email that comes in, it has to make a call. Is this junk or is this important? Well, a medical AI faces a very similar choice, just with, much higher stakes.
First up, you have what's called a positive case. In our email world, that's simple, it's a spam email. In medicine, it's when a patient actually has the disease we're looking for. This is the stuff we want the AI to catch.
And on the flip side, you've got the negative case. That's the important email you've been waiting for, or, in the medical world, a perfectly healthy patient. This is the stuff we want the AI to correctly ignore.
So here's the tricky part. The AI is basically juggling two different goals at the same time. It has to be sensitive enough to find all the real diseases, those positive cases, but it also has to be smart enough not to raise a bunch of false alarms for healthy people, the negative cases. It is a really delicate balancing act.
All right, so with that balancing act in our heads, let's go back to our chart. All of those colorful lines, they're basically a picture of how well the AI is doing that exact juggling act for different diseases.
First things first, your eye is probably drawn to that dashed line cutting right through the middle. You can think of that as our baseline. That line represents an AI that's just guessing, literally flipping a coin. Any model performing on or below that line is basically useless.
Now, let's see what a good model looks like. The higher up a line goes, the better it is at catching the disease. The further to the left it stays, the fewer mistakes it makes on healthy people, so you want a curve that shoots up and to the left. See that yellow line for emphysema? It pulls way up there. That tells us it's fantastic at finding the disease while rarely making a mistake. That's a star student right there.
But now, contrast that with the green line for hernia. See how much closer it is to that diagonal line of chance? This means that for the AI to catch more true cases, it has to make a whole lot more mistakes on healthy patients. The model is really struggling to tell the difference.
Okay, so comparing the shapes of all these squiggly lines is useful, but it's also kind of messy. Wouldn't it be great if we could just boil each curve down to a single, simple grade, a final score? Well, it turns out we can. It's called the AUC, which stands for area under the curve. And it's pretty much what it sounds like. It's a single number from 0 to 1 that just measures the total area living underneath one of those colored lines. The bigger the area, the better the AI's performance. It's the final grade. Simple as that. A perfect score? That's a 1.0. This would mean the AI correctly identified every single positive case and every single negative case. 0 errors. An absolutely flawless performance. And what's a bad score? Well, a 0.5. A score of 0.5 is our coin flipping line. An AI with an AUC of 0.5 is no better than just random guessing. So how did our AI actually do? Well, here's the thing. Its performance is all over the map. It's a top performer, an absolute rock star for conditions like emphysema with a super impressive score of 0.935. But then you look at hernia, 0.644. That's, barely a passing grade. So what's the big takeaway from all this? What do these scores really tell us about the future of AI in the doctor's office? The most important lesson here is that an AI isn't just good or bad. Its ability is incredibly specific. This model is an A+ student at finding emphysema, but it's barely passing when it comes to hernias. And this is exactly why this kind of rigorous disease-by-disease testing is absolutely essential before we let these tools into our hospitals. Ultimately, it all comes down to this really simple but profound idea that the source material for this chart highlights. It's about the ability to discriminate between positive and negative cases. Can it reliably tell the difference between sick and healthy? This chart is the tool that gives us the answer. And that leaves us with a final, really crucial question. A performance score of over 0.93, like we saw with emphysema, isn't perfect, but it's incredibly strong. So when is very good good enough?
That's the complex but super important conversation we all need to be having as AI becomes a bigger part of our healthcare.